Today I'm going to make a hanger for 2 brooms that goes in the laundry. It's based on the principle of cams, and I'm using 100% salvaged wood cut with a jigsaw and assembled using a hand drill and screws. I'm going to introduce the concept and how I got my inspiration from it. And then I'm going to design a basic mock-up in Fusion 360 from Autodesk, and then I'm going to try and print out some templates and then cut the pieces and assemble them using a jigsaw and a hand drill. First of all, we need some inspiration for our project. A simple Google search and some candidates from, say, Pinterest are a very good start. Here we have the first page of the hits on Google image search. So we can see this concept over here. It has a rotating cam which has a shorter radius at the bottom, and then as the cam closes it has a longer radius, which means that the gap between the end stop and the cam face reduces as as gravitational load is pulling downwards on the cam. So this is the fundamental concept we want to try and duplicate using a homemade method. Financially it doesn't necessarily make sense because this is probably a very inexpensive part. $30, $40 for 12, but we're not here for the cash saving, we're here for building things from garbage. On the first tile there's some wooden cams that are made. These are not actually intended for holding brooms, but rather holding heavy vices in a workshop, and here we have a 3D printed cam that holds a broom. So we can see these two concepts are going to contribute quite strongly to my project. Also we have the designer one, which is made out of what looks like round cut ply. So let's quickly look at this one and see how it works. So we're done with the research of what we want to do. We know we want to build a cam. We know that the cam needs to pinch up against an end stop as the broom pulls down, and we know we need to use the wood we have on hand. So I'm going to show you the pieces of wood I have to work with today, and then we're going to go over to Fusion 360 and mock up design. So first off, I've got my cams. This piece I'm going to cut into the teardrop shaped cams that will pinch up against the end stop as the broom pulls down. I'm not sure if I'm going to use this for the end stop as well. We'll see how things go when we're modeling. This, I think, is a sink cutout. You can see from where they did a plunge cut over there and then started to cut the outline, and since I brought it home I squared off this face in anticipation of cutting a rectangular piece out of the bulk of it for a different project. So I'm going to try and concentrate my cams in this region over here, making the back plate a little bit wider than the sum of the cam and the end stop. So I did a simple hand sketch with a pencil and paper, the engineer's 2 most important tools, just to try and get a rough idea of the dimensions. So what you can see over here, this is got the working parts from all 3 of the different cam designs that I showed from Pinterest and Google. So first of all, you've got the cam in the left hand side of the image, and I estimate that the axis of the cam will have a diameter of 20 millimeters. And then on the other dimensions of the cam is that the short side of the cam will be about 10 millimeters from the edge, and the long side of the cam will be 30. And if I look at where the end stop is, this vertical bar, I want to look at some dimensions from that moving left. So I have the vertical bar, which I thumbsucked to be 18 millimeters, which is a standard stock of plywood that I have. My thought is that the broom will be somewhere between 15 and 35 millimeters in diameter, and with those are the absolute ranges of the cam. So when the cam is fully open, I'll have a 35 millimeter gap, and with the cam fully closed, I'll have 15. So I just need to confirm that the broomsticks are within those diameters. Now this is a 2D drawing, so what I'm missing from here is the depth dimension. So if my assumption is that the broomstick is about 1 inch in diameter, 25 mils or so, and I'm going to confirm that before we proceed. and that means that the cam itself needs to be covering from the back. It needs to be about 25 millimeters with some range. So my thought is, if I use a piece of this material, which is clearly thicker than a broomstick, for my cam, I should be okay. If I wanted to use the 18 millimeter ply, I would need to potentially space it forward, and then I need to add something sticky, possibly hot glue. That's my first approach, and possibly if hot glue doesn't work, then I can go and use sandpaper, kind of like a skateboard design concept. So first of all, we're going to switch to the top view. I know a lot of people prefer different views, but that's just how I am. So I'm going to start off with drawing the circle of the axis of the cam, and then spacing it to the vertical bar that holds the broomstick when the cam is pressing up against it. And I'm not quite sure how I'm going to do the cam shape itself, but let's start off with a few concentric circles just to keep things simple. So, concentric circle on the sketch plane. Start off with the 20 millimeter axis for the shaft. Then we know we want 10 millimeters more than that 20 for the narrow part of the cam. So let's be lazy and do hotkey D for dimension. Put this in over here. Now I assume D1 is the 20 millimeters, so let's do that plus 10. Yeah, it works. Okay. And then I know I need to go another 20. So that will be create a new circle, hotkey C. Create a new dimension just to the outside here. Now this should be D1 plus 30, I think. Yeah, so that can be D1 plus 30, or it can be D2 plus 20, depending on how I feel. So both of those give us the same. I'll go D1 plus 30, just to keep it all tied to the first dimension. So now we know we have 50, 30, 20, and also we need a 10 millimeter spacing from here up until the vertical bar. So I'm going to start off just by constraining this to be vertical. Oh, it's already vertical by chance. And then I'm going to create a dimension from this to this center axis. That should be, I think, 40. Math is a little bit rusty right now. No, it should be less than 40. Okay, let's see what the dimension is from the edge here. Okay, it won't let me do that. I need to do a measure. Let's see what my measure is. Measure. Here we go. So I'm going to measure from the edge there to here. That's 10 millimeters. It should be 15, so I'm going to space this up to 40. Okay, I spent a few minutes playing offline, and I have a strategy for how I'm going to get my cam shape. So my thought is to make a circle with 40 millimeter radius as a construction line in between, and then to create a spline that goes through the 30 millimeter at the top, the 40 millimeters on each side, and then the 50 millimeters at the bottom, and then that'll get me my tear-shaped cam, which I think should do what I want. Okay, perfect. Maybe it will work, maybe it won't work. Let's give it a try. So I have no warnings this time around, which is great. So that means I should be able to perform an extrude of these three, and let me do just those at once. So let's check how thick our material is. Trusty caliper. $33 millimeters. Okay. And we should edit this feature and neglect the center core. Okay. And then let's create a different extrusion of this back plate. Okay. 33 millimeters for that. And then we have a cam and a backboard. So it feels to me like the camming is a bit aggressive between the low point and the high point. So I think what I'm going to do is reduce the diameter of this midpoint circle and see if it becomes more aesthetically pleasing. Ah, that's better. Okay, so let's hide the sketch, and I think that looks a bit more likely to work. So I cut out this small egg-shaped template, and because I'm being a bit lazy and not really planning ahead, what I'm going to do is just hold it over. I'm going to first of all make a small hole at the center, approximately at the center. I'm going to hold it over the wood, and then go from the center outwards with a Sharpie to create a line. Then I'm going to cut it with a jigsaw and just drill out the hole in the middle and clamp it onto or put it in with a single screw and see if it works before trying to take a more advanced approach at creating a wooden axle. Okay, so I finished doing my stenciling. Kind of looks like a pair of eyes. I used the center punch to press out the hole into the wood. So I basically pressed with that into the center of the hole into the wood, and then went outwards to create my line. So I've cut and drilled my two cams. They're not perfect, but they have the key ingredients, which is they have an axle hole, they have a rounded surface, and they are wider on one point than on another point. So given a back plate over here on this side, and a support, and some sort of friction creating material on this face, we might have something that works. So the next thing I'm going to do is to cut out something that's representative of this bar on the right hand side of the egg-shaped cam. So I've squared off my backplate material on the one face. What I'm going to do is use my engineering square to measure and square off a second line. And then I'm going to use these two lines, this newly cut line and the drawn line, to create two equisized rectangles for the first two versions of the cam clamp. These pipe holes a bit deeper. Okay, so let's get some screws. Yeah, so okay, that's right. Around the border side, I'm going to just use more today. 1, 2. So let's go 1, 2. To the side. Yeah, on this section. Now use the 4 side to the side. Okay, I'm going to put down the little handles. Put these in my hand. So times, and then we'll switch across and put the times. So yeah, good. There is that, right? Okay, so I'll do the last project is making a hole. So hand fighting. This needs to be big enough in one location, this one the nail. Just to give us some confidence here. Here's a nail. Rotate. I think that's the place. And now make a little stick. So that we can put it around our nails. Okay, so let's see this. Okay, so I'll just get that bit of this table. Everybody. Okay, and let's just stretch the beating. Okay, so we're good. I'm going to take all this because it seems like I can go through. Just take out the handle. Pretty hard. And that's just my knees. So this is looking good. 1, 2. Okay, just keep this stretching. So let's see what's. So this is assembled. If I pinch it, it clamps, but it feels like it's a little bit too tight. This you can see the clamp is not wide enough for this particular broomstick. So let's check this one. Definitely not. So my plan was to put something sticky on this face. If I do the same process on here and on here, it'll add maybe 2 millimeters on either side, which will take away all of the tolerancing problems I produced. So let's give that a go. Put 2 holes in the top and the bottom, hang it on the wall and see what happens. And then off the video I'll assemble the second one. So after covering the faces with some hot glue, specifically I did some runs perpendicular to where the broomstick is going, and then just a general rough application on this face just to create some friction. It seems to work quite nicely. So if I just hold it by hand and I drop the broom in, it bites quite nicely. And let's try the second broomstick, the metal one. Okay, this one, it's a little bit closer to the edge as far as the tolerancing goes, but it seems to bite quite nicely. The nice thing about the friction is you can just sort of pop it in and pull it down and it finds its way to the cam point because it sticks along the cam, but less so along this face. So it's mounted on the wall, and you can see this one, the mechanism bites with just one hand. The plan for this one is to keep it relatively close to the floor so you can step into the laundry room and access it right away. For this one you need to use one hand to activate the cam while you're dropping it in, and then it's hanging nicely.